Hi everyone, in this video we'll take an application of the first derivative. So this is the example. We have three parts, A, B, and C. And the example is an object is released from rest from a building at a height of 1,250 feet above street level. As shown, the height of the object can be modeled by the position function s equals f of t, which is equal to 1,250 minus 16t squared. And part A, verify that the object is still falling at t equals 5. Still falling means that if you replace t equal 5 in the position function, you will not get 0. Because if you get 0, this means that the object hits the ground. So you have to calculate s of 5. So plug in 5 in the given function, you will get 1,250 minus 16 multiplied by 5 squared. And this will be equal 850, and 850 not equal to 0, which means that the object is still falling. In part B, you have to find the average velocity. So you have 2 times. This is the first time, from t equals 5 to t equals 6, and you have to find the average velocity, simple as VAV, which is the average velocity. So what to do to find VAV, the average velocity? You have to replace the final time and the initial time in the position function, and we can write it as delta S over delta T. So you have to find S of the second time, S of 6 minus S of 5, divided by 6 minus 5, because we have interval of time from 5 to 6 in our question. Denominator equals to 1. In part A, we found S of 5, and this is equals to 850. So you have to find S of 6, and it's equal to 674. Then you have to subtract 850 from 674, and this is equals to negative 176, and the unit is feet per second. Pay attention here, the sign of the velocity is negative. This is because the object falling down. If the object moving up, it will be positive, but here in our question, released from rest and it's falling down. Okay, this is the direction of the motion. In part C, you have to find the instantaneous velocity, which is v instantaneous, and it is equal to the first derivative of the position function. So you have to use the definition of derivative to find s prime. So v instantaneous equal s prime of 5, because you have to find it when t equals to 5, and this is equal to limit s of x minus s of 5 divided by x minus 5 when x goes, when x goes to 5. Okay, now s of x is the function itself, so the limit will be limit of 1,250 minus 16x squared minus s of 5, and s of 5 from part A equals 850, divided by t minus 5. Here we have t when t goes to 5. Now you have to subtract these two numbers, and this is equals to 400 minus 16t squared divided by t minus 5, which give us limit of. Now you can factor out the greatest common factor, which is negative 16 multiplied by t squared minus 25 divided by t minus 5 when t goes to 5. Then you have to use the difference between two squares to factor t squared minus 25, and you will get limit of negative 16 multiplied by t plus 5 times t minus 5 divided by t minus 5 when t goes to 5. Now you have to eliminate t minus 5 with t minus 5, and you have to plug in t equals 5 in this function, and you will get minus 16 multiplied by 5 plus 5, and this gives us negative 16 times 10, which is negative 160 feet per second. Again, the sign of the velocity is negative because the object is falling down. And that's it. Thank you.